Thanks for joining, everyone. So I'm Harry, this is Paul, this is Anthony, and this is Put It to the Test. So just a couple of notes before we start. We've numbered the slides, so if you wanted to refer back to them, if you had any questions, please do, and we can hop back. If you wanted to ask a question whilst we're talking, feel free, use the chat. You can use the Q&A, we'll try and keep an eye on it. Yeah, feel free to use the chat. I noticed there's a question about engaging with mic and webcam. Not necessarily, but if it was possible, if you could ask in the text chat, that'd be great. We can put you on if you have a very specific question. We can let you on with the mic and webcam, but feel free to use the chat to initially ask a question. We will have our slides available later on our GitHub page. We'll let you know more about that later on. So yeah, we think that sorry about that. Today we're hoping to run maybe a slightly different style to usual for a workshop. We were very much inspired by the tabs and spaces talk, ADC. In particular, the way the sort of voting system happens. So what we'd like to share with you today is just some perspectives on the different areas of test-driven development and behaviour development, driven development in our various experiences in Focusrite, what works, what doesn't. So we've got a variety of topics and content that we can share with you. So that being said, there aren't really any prerequisites to this workshop. Hopefully there'll be something for everyone. We've got some basics that we can run through. We've got more, in detail discussion that we can have. Well, if we've got examples, it'll be C++, but obviously these techniques can be applied across different languages, frameworks, etc. And obviously mainly aimed at people writing software, but this could be useful for just working in a team generally, for product owners, team managers, etc. Just to get insight into how we work as software developers and the advantages of using tests, etc. What are we going to learn today? Hopefully, if we do our jobs correctly, just about testing software. As I said, basics, ways of effectively writing tests and perspectives of what we find particularly useful when we write tests. Tackling the tricky testing problems, which I'm sure will hopefully come up in the chat. How do I test X? Or it depends. Might be a bit of that today, but hopefully we'll be able to navigate all that kind of stuff. And towards the end, obviously, if you've got any particular questions you have around testing particular parts of your software, you can let us know. We can do our best to answer. Cool. So as we said earlier, depends on what you'd like to see. So we'll be running we're going to have intro section, and then we're going to have 3 sessions of just under an hour long with breaks in between. Before each one, we'll have a little poll where you can decide what you want to talk about, and we'll go through each one as for the popularity. So who are we? Who is first?
It's me. I'm Anthony Nicholls. I'm a senior software developer at Focusrite, mostly working on the Focusrite side, working with SCADA products. Previous to that, I was working at Sonox, so I worked a lot with audio plugins, have experience with that, with pace integration, did a lot of CI stuff while I was there. And I'm now working with a larger software team, Focusrite, and we're working all the way from the control software that you see working with our interfaces, but also I work a lot with a lot of tools that we use internally for our engineering department to help them improve on things like testing, so that we can get wider testing coverage. I think that sort of covers me on that.
Cool. Yeah, as I said, hi, I'm Harry. I'm a junior software developer at Focusrite. Mainly work with Anthony on similar projects, as he said, control software, using Juice for the front end, and also libraries in the back end for communicating with devices like audio interfaces. So I've been a junior software developer for 2 years now. I think I had a 2-year anniversary last week, actually, which has flown by. Before Focusrite, this was my first sort of coding job. So before that, I was at uni, did music, and also sort of dipped my toe into coding. And then I did a master's at Goldsmiths. I was actually taught in one of my modules by Rebecca Feebrink, who did a fantastic keynote the other day. It was really cool. I'm a musician, into music, and also happen to get along well with computers. So, yeah.
Cool. Yeah, so I'm Paul. So my background was in software engineering. That was what my original degree was. And I joined F-Expansion out of uni. So I was with F-Expansion for 15 years, working mainly on plugins, but also a lot of like authorization systems, so cryptography, some of the back-end security stuff in there, like how to deploy a 50 gig library to people. And this was in the days of CDs, DVDs. Since then, I moved on to working at Morley, where I was part of the blocks team. So we writing the firmware there and involved with the Littlefoot development. So I worked on the dashboard that they built there. And then I moved to Ampify, which is where I am now. So I'm lead developer for Ampify. Mainly I'm involved in the development of Ampify Studio, but also the backend C++ library that powers Ampify Studio as well as our iOS apps. I definitely focused on testing, and that's increasingly become a focus of like, how do you provide robust and stable software? That kind of covers me.
Cool. And you like fast cars?
I do like fast cars. Yeah, faster the better.
Cool. I think I covered this a bit earlier, but roughly 3 sections. We're going to do a short voting section before each one, so we can discuss a topic. We want to keep this kind of relaxed, so as I said, feel free to ask questions, and we'll kind of as you could maybe see, there's a sort of range of experiences here. So hopefully we'll be able to provide you with some different perspectives on our experience with testing software. So we've got before we do the main section, I want to maybe get some opinions from you, do a little poll, see basically what your sort of experiences are with testing, just sort of so we can gauge that. So Bobby, if you're there, would you be able to put up the first initial poll?
Yes. Sadly, it's going to take about 30 seconds. I have to relog back into the to the web page for Zoom. But if you can ad-lib a little bit for 30 seconds, it'll be on momentarily.
That's all right. Yeah, let's quickly sing a song. Sure.
No, I think worth expanding on that. Like you said, there's a range of different experiences here. So like we've got Paul, is working over at the Ampify office where we are at the moment, and he's working on works on a DAW. So there's a studio there, Ampify Studio. And there's a lot of challenges I expect there, which if you went to Joe Noel's talk on the end-to-end testing, that's the team he's been working on and where that's all come out of. And I think actually it's been quite an inspiration for certain other areas in the company for how we go about doing testing. And then on the Focusrite side, there's a lot of hardware involved, and there's a lot of challenges there in how do you deal when you've got physical hardware and you need to be able to, that needs to be involved in, say, control software, for example. And like you say, there's a real range there. I think both of us have got some plugin background. There's a bit of crossover there, but I think there's a range of Harry. He's joined us 2 years ago, and I think he's done a fantastic job on the control software. And then all the way over to the years of experience that Paul's had, going all the way out to working with CDs and DVDs and trying to ship out.
Yeah, I would definitely say the industry's changed quite a lot since those days. Not that it's new ideas to write tests. I mean, the idea of writing tests has been around since the beginning of writing software. But the plugin and audio world was a bit more lackadaisical. Back in the day, it was smaller teams, smaller companies. You could get away with things that aren't really necessarily acceptable within the industry now, just by virtue of the fact we were small teams. Whereas now, especially for a larger company, the focus has to be on providing robust software and providing it in a way that is maintainable and can go on.
Cool. So if you can see that poll on the screen, feel free to answer this. This is just for the purposes of today. We're just going to just gauge some.
I think we just wanted to gauge the audience we have and just see what where you all at in terms of testing.
I was just about to say, it's heartening how many people write tests, and then the no jumped up.
Yeah. I think we can reveal these results in a sec, so you can all see. What's that?
The poll is live. Q3 is ambiguous. Should it be tests don't work well with writing audio software?
Yeah, so with that one, we're kind of asking who finds writing tests for audio software hard or thinks they're incompatible. Yeah, if there's things that are unclear or we've written them in a slightly strange fashion, feel free to flag them.
So yes, it's hard, and no, it's easy.
Yes, it's hard. Yeah. Sorry about that. Lots of double negatives and things going on there. Cool.
Okay.
Cool. All right.
Should we end that poll?
So if we end the poll, we should be able to see the.
Yeah, we can share the results with everyone as well. I guess.
Cool. Okay. Share results. Cool. So I think you can hopefully see the results there. So we've got. Oh, okay. Interesting. So almost 50-50. He regularly writes tests when making software. I feel like that's sort of what I'd expect, actually. And then everyone wishes they wrote more tests. I think we agree. Who thinks testing doesn't work well with writing audio software? Okay, so unless people are misunderstood our wording, it sounds like people think that it's generally possible and a good thing to do.
That's good.
If not, then hopefully we'll try and convince you today in various areas. So who pays more attention to tests in a... Oh yeah, sorry, we should have expanded that. So that's a pull request. Than the main body of the code. No, I think, to be honest, personally, I would agree with that as well. I should probably read the test more. Cool, okay, interesting.
So there's a really good talk on YouTube called The Science of Unit Tests by Dave Steffen, he's a professor of physics, I believe it is. And he identifies 7 key metrics of a good test. And I've always thought they really capture what a good test is. So if we just run through them quickly. So did that work?
That's good.
Yeah, there we go.
Yeah. So the first one is obvious. It should be correct, i.e. the test should actually work. If your test doesn't work, then obviously it's not a good test. Then the test being complete, as in it covers everything required by the specification. Now, there's an interesting little sort of nuance here, which is that it should be correct based on the specification. It implies that before you start writing a test, you need to know what it is you're going to test and what you consider to be a complete test. How do you know that you've passed your test? And that goes to the first point about correctness, that if you don't know what you're testing, you can't really test it. So number 3, the test should be readable to a lay person. So one of the tests that we kind of consider is, could you show it to your product owner, your manager, somebody who's not an engineer, and could they understand that test? If you use Cucumber or Behaviour Driven Development, it quite often is broken down into scenarios and then given when then, which makes this part of writing a good test much simpler. It's much easier to write a good test when the test architecture structures it in a way that is helpful in that. Conversely, if your tests aren't readable, what's going to happen is you're going to come back to it in a year's time and not necessarily understand it. And one of the things that we will touch on again and again today is that your tests are about documenting your code. If the tests aren't readable, essentially your documentation is unreadable. And I'm sure everybody has at points hit documentation that's just, it doesn't tell you anything other than the name of the function or the name of the variables. You know, you need to make this stuff readable.
Yeah, I think just on that point you were saying about the correct and complete as well, I think if you don't know that specification, it comes into this readable aspect that the temptation is to almost over-test, and you end up testing sort of implementation details. And part of being readable, I think, is that ability to be able to go back to it and understand it again later, not just at the moment you wrote it. Tests are really important for that several years down the line, maybe even you're a different engineer to the person who wrote it in the first place, you still want to be able to understand what that test was testing. It's a really important part of it, for sure.
So the next one is demonstrability, which is a word I really struggle with, which is about it should demonstratively be working and correct. So I always took this to be that you can see the test passing, that it's easy to understand. There's some output from your test runner, shows you that it's working. You can see in something like CI, like continuous integration, that the test is working and you're getting some sort of output from it that tells you that the test is doing what you expect it to be doing.
So this is really just that you're running the tests on a regular basis, basically, to make sure it continues to work.
Yeah. So the next one is resilient to failure. This is one that gets every engineer at some point, is you write a test and then it fails for reasons you don't understand. So I recently wrote a piece of code, and about 1 in every 400 or 500 times it ran, it would fail because I created a random number generator, and then when I refactored it, I made the function static. And that had the effect of meaning that the random number generator wasn't quite as random as I was expecting it to be. Now, 400 or 500 failures doesn't, like if that's 1 in 400 or 500 runs, it would fail. Doesn't sound like that much, but we test every commit on a pull request. And everything that goes into develop is tested as well. So we might run several hundred builds in a week, which means that 1 build a week is failing. That very quickly builds up. So you want your tests to be simple enough that they're going to run reliably. It's also when they fail, they should fail in a way that means you can very quickly identify why they're failing. The worst thing is a test that you can't understand what the failure case is. Easy and fast to run. This one is, I think, one of the biggest things about introducing a testing culture. So if you want to bring a testing culture to your team, make the tests easy to run, fast to run start to completion. The other thing is make it easy for engineers to add new tests. If an engineer has to understand 50 layers of code, if they have to look at documentation every time they're trying to write a test, if it takes 4 hours to run your tests, the engineers are going to stop. They're not going to bother doing it. Whereas if you make it, you know, npm run test, and it takes a couple of minutes, that makes it easier for engineers to run it reliably, regularly. The other thing is if it's easy to run it and it's fast, you can run them against every commit, ideally on CI. And yeah, so the last one is about deterministic. So the test should run in a repeatable fashion and should provide consistent and expected output. So referring back to my random number generator, you shouldn't really have randomized stuff in tests. All the really big mistakes I've made in tests have been when I've introduced randomness into them, because you can no longer rely on the fact that, well, did it fail because it was a random number that went in that the code didn't like, or did it fail because the random number generator didn't generate me a number that I was expecting?
Yeah.
It also means that it's very hard to debug it because you don't necessarily know what randomized information you pushed in there.
Yeah, it's like the sort of scientific thing of only changing one thing. Like if you're, I guess you're referring to like random as a sort of input.
It's an input to the test,
like
yeah.
You want to know, your test should describe, okay, when this one thing changes, when I do this, do I get the like expected output? If you've got this other thing changing, it can be very confusing. Do you have any kind of random sort of things that use random in like products?
No, not anymore. So the only place we use random is to generate white noise as part of testing audio algorithms. So when we're testing audio, we use two inputs. One is a sine wave, because they show up clicks really, really easily. And the other one is white noise, because we can then do spectral analysis on it, because we know the spectrum as it goes in should be just essentially flat. Right. And when it comes out, does it represent the expected outcome? But yeah, generally we don't tend to do randomized.
I think the only ones I can think of I've used that was useful just to get some confidence was it itself was a random number generator, and there was edge cases, so we made sure we covered all the edge cases we thought we need to cover, but there was an element of just making sure in certain cases. So we had kind of an iteration that went through and tried randoms, but the key thing there was to understand that input was just making sure we captured the seed. And I know Juice is quite good with this. You know, if you use the random number, it gives you a random number generator as part of the Juice unit test. And the nice thing is it captures that seed. So at least if it does go wrong, but I think you don't want to rely on it. You don't want to be like, I'm just going to do a random number generator and just throw those in. You kind of want to know what you're really testing. And if you really, really feel like you need to test some edge case, maybe. Although I'd even be tempted that after some time, I might even switch that off once I have got a certain level of confidence. But yeah, I think at least capturing, if you are going to at least capturing that random seed, so that you could at least come back and reproduce it, because you never want to get into a situation and go, it failed and I can't reproduce it. That'd be the worst thing. Yeah.
So if we take those 7 as like a good starting point, if you cover those 7, you're likely to have a good test. But one of the things that I think is definitely worth remembering is that any test that's good is better than not having any tests. The more tests you start to add to your code base, the more confidence you'll have going forwards. And you have to start somewhere. So start with any test that you can fit in. Try and make it comply with those 7 key rules. And if you do that, you'll start to see places where you can add those extra tests. Yeah. The other thing to remember is that you don't actually have to use any kind of framework. There's lots of frameworks out there. You can just use the assert, or, you know, even just a print line is fine for the first step. The main thing is, though, if you use a framework, it will make your life easier, simpler. It will make adding new tests easier. It'll let you do a lot of stuff like automatic reporting in CI. So, you know, if your options are no tests or an assert, go with the assert. If your options are I've got time to look at a framework, go with that. Frameworks definitely help.
Yeah, I think adding on that assert point as well. I mean, in the case of C++, actually, if you can do a static assert, if it's something you can actually confirm at compile time, then it's really worth doing, because you know you're going to run that every time you're building. So you've got that case where it won't even build if you error in that scenario. So it's always worth looking for that. If it's possible to do a static assert, I think it's actually worth doing them.
One thing that I found kind of revelatory was a few years ago. I watched a talk about TDD at CPPCon, and the speaker basically made the point that for a language like JavaScript, TDD is, you know, you need that run step. But with a language like C++, because you've got a compiler, that is part of the testing. The fact that you can compile the code or it doesn't compile, and you can use static asserts, you're implicitly defining the behavior of that code. And if you can do that, like you say, at compile time, that's a really powerful tool. So we will talk more about the last point here, which is make sure something like CI runs your tests. We'll talk more about that later, hopefully. But yeah, if nothing's running your tests, are you really testing it at all? Or, you know, how do you know going forward whether you've broken some or all parts of your code when you make changes? You need that as the additional step at the end to say, okay, something's going to run it. And again, it's like if your options are, you know, if you don't have a CI currently, if nothing does your automated builds, setting up something which I've seen before, like a pre-commit hook that will call a script, that's a good first step. You know, if you can then start looking at, you know, some sort of CI, that's also good. There's lots of free and open source tools out there that will let you run local builds. You don't have to go and get a big hosted cloud provider.
I think also that, and part of that, you know, making sure you run your tests. You know, you want to run those tests, and forever as you develop that software, you want those tests to be run. And that's why, going back to that point about, you know, making sure that your tests, essentially they're useful, right? That when they fail, you understand what the failure is. That's why that's so important. I mean, it's hard to know what's coming up, you know, several years down the line, how it might grow. It might just be you for now, but who knows? Maybe it's going to be a team that grows. Maybe someone else takes it over. Or maybe even yourself, you go back into it and you go, okay, it's failing now, but I don't really understand why. And that's why it's really important. I think if you can consider that when you write a test, I think that really is, for me, it was a fundamental change in realizing how to write a better test, was taking that consideration in, hold on, what is it I want someone to gain from this when it fails? Not what am I testing right now, but what am I actually going to gain from this when it fails? I find that really useful.
Cool. So the next couple of topics are, we've got understanding the testing pyramid and what do you test. So I think the pyramid's part of this stuff here. So if we go, what do you test?
I think this does cover the pyramid as well. Before we move on, were there any questions about the last section? Feel free to just post things in the Q&A or the chat window. If we're going too fast, too slow, just let us know. We can alter what we're doing. Cool. I guess should we keep going on that one?
Naive answer. We test everything. However, with most of these questions that have come up at ADC, it depends, which is the sort of lawyer version. Pace is good. Okay, cool. We will carry on at this pace then. Thank you very much. So hopefully we'll dive into that a bit more. So as if you went to Joe Noel's talk, you'll know that he covered this pyramid. And as he said, pedants among us, it's actually a triangle, but who knows, there might be some other hidden side that we're not aware of. We haven't found that one out yet. However, yes, as you can see, there's this triangle here. So there are loads of different kinds of tests. A good resource on this, I guess, is Martin Fowler's website, right? Because he covers, all the different kinds of tests, which can be easy. It can be kind of daunting at first, but I think beginning with understanding the main sort of three areas, which are unit tests, acceptance, also integration tests, and then the end-to-end tests, which we had a talk on Monday. It's hopefully a little bit easier to understand. So yeah, what we got? Did that one? If not, I'll do it.
Okay.
So the idea with the whole idea of the triangle is the width is sort of the amount of tests you do at that level. So you want most of your tests to be unit tests, which are testing the core, low level features of your application, which is I guess public interface of your classes, right? At the kind of smallest level. And then as you go up, you join those sort of objects together and sort of test them together. What that actually means in practice, I guess, is the thing that can depend, because you can choose to test different things together, and you kind of have to decide, right, what do I need to test here? I think maybe if I just look at what the next thing is, general guidance, I guess, is particularly if working on an app or something, is what would be, again, it's kind of hard to define, but what would be embarrassing if it failed in your app? Like, you want to maybe, for example, from a user point of view, test the things that the user will do regularly. I think we've used the phrase kind of testing the happy path, right, quite a bit. So you wanna test the start by testing the main core areas, rather than worrying too much about tiny edge cases and details.
I think as engineers, we have a tendency to be thinking about all these edge cases, and it's easy to let yourself get a bit lost on that when you're writing tests. Actually, probably the first place to start is to really just test that happy path, that like, what do I actually want this to do? Not like, what are all these possible different edge cases I've got? It's not that they're a terrible thing to do. You may want to think about the different ways it could be used, but you really want to say, well, we're building this feature. This is the thing we're building for the user. Let's test that first. Let's make sure that actually works first. And that's the bit that if it went wrong, that's embarrassing, right? Like, if it doesn't do the core thing it's supposed to, it's great that it captures all these errors and all these exceptions, but it doesn't actually do what it's supposed to do. That would be much more embarrassing.
Yeah, indeed.
Indeed. I think the other thing to say about the happy path testing is that if you do behaviour driven development, you're implicitly testing that happy path, because you're testing the interface to your code before you've written the implementation. So you don't tend to handle errors where you've gone, well, maybe this is an error case, maybe it's not. You're implicitly only handling those places where you know that there could potentially be an error case. And hopefully it means that if you design the interface well, you can reduce that kind of the range of errors that you might be required to handle.
I found it's useful thinking of test code as like just client code to the thing that you're testing. So like, particularly with behavior driven development, which we'll hopefully touch on later, it's saying, okay, when I've got this thing that I've made, it rather than what can sometimes happen with the traditional TDD approach, which is just it's just code testing code. It's easier thinking a bit more as a client kind of thing, if you see what I mean, like testing it.
Yeah, the nice thing about that as well is if you think of your test code as a client, that's where it comes in the documentation kind of side that Paul referred to a bit earlier on, that it becomes documentation because you're using it just as a client would use that code.
Yeah. Just see what the next slide is. So I think we've basically said this, where it's all about pragmatism, really. You've got to decide what's best for your app, and understand the relevance of tests. So
I think the other thing to sort of home in on there is you mentioned briefly earlier about the public interface, and there's an element of thinking about, when you think about what do you test, there's an element of thinking about what you don't test. And the thing I've learned over the years is trying to avoid that. We've actually got a slide on it. Sorry there. Yeah. So just making sure that you don't go down that path of testing the implementation details. Like if you've got private methods, even though I normally go for free functions over the private methods, but regardless, if you've got those private details, they're probably not the things you want to test, because you really just want to test that public interface. That can make your test a bit brittle, and it's not. Often you'll find later, even when you think you are. I mean, like me and Harry done some testing in Python at one point, and we weren't using the sort of behaviour driven development style. And no matter how much we thought we were making good tests, later on some of those failed, and it was hard for us to understand them. And it turned out we were actually testing implementation details. And that also often happens when you're not doing it test driven. When you're writing the code, and go, right, I want to test that code. You know how it works. You've got this sort of inside knowledge to it, and your temptation will just be to test like what, you're basically just rewriting the code again from another angle, and that's not quite what you want to do when you want to write tests, because that makes your test quite brittle.
Yeah, I mean, we think of two things actually. So I guess the general guidance is you test the public interface. I found sometimes working on some of our libraries and app code where implementation is there's quite a lot of implementation and not a lot of interface. And I think maybe there's two things. The first thing, I guess, don't worry, because you're testing a public interface. That's what you are going to use at the end of the day. The other thing is that might be a sign that you need to split things up more, so that you have more public interfaces to test.
It comes down to that single responsibility principle, doesn't it? It suggests that there's a possibility that maybe something is doing too much.
Yeah.
And yes, still at the end of the day, you're saying, hey, this is the public interface, this is what it should do. And as long as it does the thing it's supposed to do in the way it's supposed to do it, then it's fine. How the actual implementation details of how it does that are not really particularly relevant, as long as it's doing the job it's supposed to do.
What would be an example? I'm going to put you on the spot here. What would be an example of an implementation detail that you don't want to test?
That's a really good question. I mean, the most obvious is when you refactor stuff and you've got some private methods. For me, it's like the temptation is to start testing those private methods and go, well, it's a method all on its own, right? I'm gonna test that. But all too often, I find that somewhere down the line, another refactor comes in and you want to change it. The last thing you want to do is change the public interface. This is how I use it, and then suddenly your tests start breaking and you have to fix your tests based off of that. And then you're going, well, the test didn't really break. The whole thing does what it was supposed to do. I've just, this private method just works differently, which is an internal implementation detail that's not really relevant to the wider interface.
Yeah.
Oh, we've got a question on that.
First question. Awesome. How would you evidence experience with testing? For example, would you try to compile a portfolio of tests you have created or been executing on projects, or would you share your test methods on your? Oh, I see.
So I'm assuming this is about showing potential employers what you're doing. Is that right, Oberon? Because when we interview people, it tends to be that what we're looking for is their understanding. So I can't remember having ever said to somebody, "Can I see your tests?" But when we interview people, we're often saying to them, how would you approach this problem? Or I mean, we have like our interview process is very structured. So we send people tests, which are, you have a short period to solve a very specific problem. If you get through that stage, we then will invite you in to do a sort of guided problem solving exercise. And we quite often use one called Gilded Rose, which is, it's essentially a refactoring exercise. And what we're actually looking for in that is not whether the person can solve the problem and not whether they can refactor the code. It's how they approach that refactoring, because the example has no tests. So, for example, we've hired people who've literally just written a bunch of tests to prove the current behavior and haven't touched the main code, because it shows a way of thinking and a way of approaching a code base. It's like I think test-driven and behavior-driven development are something that's more of it's a mindset for an engineer. It's something you need to take on and kind of invert your thinking, especially for sort of people who've been through the sort of university system of, you go to university, you learn computer science. Quite often, testing doesn't come up. I mean, my degree was software engineering, like I mentioned before, but the subtitle to that was software engineering for safety critical systems. So my degree was actually about building stuff that if it fails, somebody's going to die. Now, interestingly, the first time I came across testing was not at university. It was after I'd finished university. So, it's something where I approach code as you write it, you run it, does it work? Great, and the taking on board test-driven development and behavior-driven development involves you inverting the way you think about your code and the way you approach your code. Now I see the code that is output from our team is kind of a byproduct of the tests. The tests are what we write, and you get the main code as a kind of freebie out of the back end of it. I mean, to be honest, it's not like we always work that way. I think it's a very, very unusual engineer who can say, I am truly 100% behavior-driven, that doesn't kind of go, oh, I just need to tweak that, or I need to fix that, or, I need to go in.
Yeah, that's made me think. I sort of heard a kind of school of thought of doing this stuff. It can be very easy to say, yes, I always do behavior-driven development, and we can touch on the cycle. We can go into a bit more detail later, but essentially you write your test, make it pass. You write a test, it fails, you then make it pass, and then you can refactor what you've got to make it better, include readability, make it cleaner, so long as the test still passes. But if you're sort of creating a project from scratch, it can be hard to even know what you like. You might have an end goal, but in terms of thinking like higher level things like architecture, things like GUI architecture patterns, like where you've got sort of model, view, presenter, that kind of stuff, where you kind of need to sort of investigate a bit. So I guess either you could do a kind of time box experiment to be like, okay, how sort of maybe would this look, or you think about the public interface in sort of its entirety first. So you think like, oh, okay, I might need a setter, a getter, I might need to be able to do this, and then you can sort of maybe start doing that, like start that cycle off. Then obviously you don't then just do everything. You then go back to just doing the single thing that you want to do, but just thinking about the interface first and then diving in. Do you see? Does that kind of?
I think cucumber tests, I know I mentioned them earlier, but cucumber tests are something that I think definitely helps with this, because when you approach the problem, so your problem should usually be user focused. So my user wants X to happen when they click this button. So what you can start doing is thinking to yourself, okay, so what does that actually mean in terms of a statement of intent? So when button is clicked, X must happen within this time frame, in this way. And you can break it down into essentially a small subset of specifications, usually a sentence each. And what's really amazing about that process is how closely that will map to your tests.
Yeah, we've sort of gone on time there, but just one other thing I just wanted to add on that. We didn't point on that, dependencies, but I think if you were to go back and watch Joe Noel's talk, he covers this quite nicely actually in saying what in their end-to-end test they didn't test. And it's just that, that thing of saying, if you're relying on a third-party dependency, let's say like Juice Framework or Smart Framework Qt or whatever it is, like that doesn't necessarily need to be covered in your tests. It might well be by virtue in some way or another, but that's not the important part of your test. You're just you're testing this intent. You're like you said, you're thinking about what is this user doing, or even if you're writing some library code or something that maybe be consumed in some way, you're thinking about how is a developer using this thing? Like they're going to want to do X, and how do they use it? And the only other thing I wanted to add on to what you said, Harry, was just that, sometimes, and there's a good talk, maybe I could link it up later, but there's sometimes it's good to go off and you might write a load of tests, like the kind of tests I said earlier that you shouldn't really have. And you might write them to get into a good place, and then you might delete a load of them. And you might just be left with the ones that are really useful when they fail later. And I think like sometimes you need to write a bunch of tests to just get your head around it, to understand what is this thing doing and how's it even doing it. We've done it with something preparing for this, where we went off one path, we were refactoring something, and then once we understood it, we actually deleted what we did and went, right, now we know how to really test this thing. And sometimes you've got to be prepared to just go back on yourself and learn from your experience.
So in terms of automating your tests, is this? Yes, cool. So yeah, tests are great, but if nothing runs them, are you actually testing?
If the tree falls in the forest.
yeah. I think I've got an alternative version of that. The point of a test is so that you have confidence going forwards that you've not broken something, that you have actually built the thing you said you're going to build, that there's not some side effect from the code you're adding that's going in and damaging other code. And you want your tests to build up over time to give you that confidence that when you refactor code, that when you change it, when you add new features, you're not breaking something else. So CI is is an automated way of running your tests. It can do other things. So CI is continuous integration. It's the modern form of CI is usually something in the cloud. It will, generally it will be some sort of virtual machine-based system. It will start up, it will clone your code, build your application, run your tests, and then finish up. It will report that information to you. It can give you sort of interesting insights into what's happening with your code. It can show you tests that fail or that are flaky. But it can also be, it can be on-premise, which would be, a computer in the corner of your room running something like Jenkins is the classic one that people run on-prem. But you can also, if you want to pay the money, Circle CI will let you run on-premise instances. But it can also be, in the cloud. My biggest recommendation here is use a cloud provider. It will take away so much of your pain and let you focus on the bits that you need to focus on. When you have it running on-premise, which we did for all of F expansion was run on-premise, all of Rolly was on-premise, or all of the stuff that I did with Rolly was on-premise. You are then taking on board all of the setup costs. You've got to maintain the hardware. You've got to be on top of is it a clean instance each time? If there's multiple teams working on it, have they each got a clean VM or have they got their own machine each? If you use a cloud provider, you get a clean instance every time. You know exactly where you're starting from and you know where you're going to.
Yeah, it can have a real impact on your tests actually, because if that environment, if you're running on premises, the most common sort of way of doing it, at least especially when you're having to deal with things like Mac OS or something, is that you've just got some computer running, like you said, like a Mac Mini or something, and sitting in the corner, and it connects up to Jenkins or GitLab or whatever else it is you have that's sort of saying, hey, do this thing, and it runs the build just like it would on a cloud provider. But the difference is, over time, the environment on that machine can change. And even just running and building your thing could do something that changes it, such that the next time you run it, it doesn't behave the same. And that's the last thing you want. You want that repeatability. I think, you had that earlier in the sort of 7 points about what makes a good test. And the environment of the machine, if it's changing all the time, then it might not be very repeatable. And it's good to know that you have the confidence in that repeatability. So I'm totally with you. I think cloud providers are the way to go. That being said, that there can be difficulties. I could probably point you to a talk I did a few years ago where, I was working at Sonox and we had to be on-prem for all sorts of reasons. And we did find a way to make sure we got that repeatability aspect of it, but it's a lot of work, and if you can avoid it, you really do want to avoid it. I should point out as well, for GitHub Actions is good for this. If you're on GitHub Actions and you've got an open source project, it's free, and you can actually do, if let's say you have one part, like often plugins, for example, you might need to, maybe in the build process, you need to sign with a Pace iLock plugged in or something. For one, speak to them because it might better help you, but 2, even if you do have to run that on a machine, you can just have that one step run on the machine. So you've isolated the bit that's not so reliable to being just down to that one thing, and then it probably is quite reliable.
In terms of the Pace Eden thing, I actually went to a talk at ADC where Eleonora told us that Pace now has a command line interface application which will let you sign without needing a key.
Yes,
you just need the right environment set up.
Yeah, absolutely. You can absolutely do that. But let's say for some reason, another one is Windows sign-in, right?
Yeah.
If you're in the sort of professional environment. But something might hold you back, and GitHub Actions actually lets you do both. So you can have the cloud and you can have the local runners connected, and you can do that for free if you've got an open source project, I believe, on GitHub Actions. So there's not really any excuse for not doing CI, I don't think, anymore.
Yeah. And CI will solve a lot of problems for you. In terms of when things become more automated, your team will start to rely on things happening. For example, with Ampify Studio, anytime a pull request is opened, we kick off a CI process, which builds Ampify Studio on all of the platforms, which is currently Windows, Mac Intel, and Mac Apple Silicon. So it will build it on all those 3 platforms. Now, interestingly, it will build those in parallel. It will then run our unit tests, our integration tests, and our end-to-end tests. And again, it runs those all as parallel processes. It gives you loads of information about what's failing, when it's failing, how often it's failing. I can go in and look at metrics about how often my team deploys to users. I can learn information about how long builds take. We can get good information about, how long does it take to start up and shut down the application, for example, will come straight from our tests, because you can see how long each of the tests take and you can amortize that cost.
Yeah, I guess the important point to make there is, you mentioned earlier about, you don't have to have a framework when you're doing the unit testing, but if you do go for one, when you're picking one, looking for one that gives you JUnit outputs. Yeah, it's a really nice feature. You may not need it straight away, but at some point, if you're using CI, it's really useful because most CI providers have some way for you to take that JUnit output, which basically just says, hey, this is the name of the test that run, here's how long it took, here's whether it passed or failed. And then you can see that really clearly in a nice UI. Yeah. And Circle CI even has a neat feature now where it can tell you things like flaky tests. It's like, hey, that passed here and then it failed and it passed and it passed and it failed. That seems a bit flaky, that test. Going back to your one in a 400, 500, and you go, you might have a flaky test here. Yeah.
The other thing to say there is about JUnit output is if you're using CMake, first stop on your list should be CTest. So CMake has a built-in testing client, which is what we use for our unit tests. It outputs now, as of 23.21, it will now natively output JUnit in the right format for Circle CI. You can just upload it as a specific step. yeah, big fan of CMake and CTest. They, you know, just work.
Because also, if running on a cloud CI with CTest, you can set the timeout, right?
Yeah.
So you can make sure if you've got a test that hangs for some reason, and you don't want that just hanging on a cloud server for ages, because that can cost, right? So you can set the timeout.
Yeah, we set ours for 3 minutes, I think it is, because any test that hasn't put out some output in 3 minutes, something's gone wrong there.
Yes.
So in terms of cloud providers, we in Focusrite, Ampify, and Novation, we use Circle CI. So really good cross-platform solution. They support Mac, Windows, Linux. You can use Docker containers, which we use quite a lot. The big problem with Circle CI is pricey if you want to do a closed source solution. They charge you per minute of compute time. And if you want to go and do some of the things that we need to do, like being able to, run shared containers or stuff behind our firewall, which we need for code signing, then they really will charge you quite a lot of money. But their services are, really quite impressive selection of tools there.
Yeah, I think the other one to just jump on here, which again may be important for your test if you want to, especially as you get into the end-to-end test stuff, is so GitHub Actions has a lot of very similar features. If you've looked at it, you'd see that it's quite comparable in that sense. But what it's not so good at is it doesn't offer as many options, say, for different versions of macOS you want to run on. So if you want to get that good coverage going back across different OSs, then Circle CI tends to be a lot better for that. Whereas GitHub Action tends to be only offering the very latest version of macOS, sometimes 2 versions. So yeah, just if you're really getting deep into it, I would say don't worry about those details too much if you've not quite got to the point you're writing tests. But
so other CI providers, Bitrise. We used Bitrise for a long time. Really good iOS support. They've got a really nicely integrated sort of deployment framework. Appvea, we used Appvea as well. So it was the cheapest of all the CI providers we used. It was quite bare bones, but it did the job. We originally used it because nobody else supported Windows. That was the big feature that they gave us. The sort of new one on the block, GitHub Actions. You get a certain number of minutes free with your GitHub account. If you want to start somewhere, start with GitHub Actions. It's really quite a simple interface. It's being built out at a rapid pace now. There's lots of open source projects using it. So yeah, that's a good one to, you can start using that tonight to start doing automated stuff. The last one in our list here, if my mouse would move, there we go. Microsoft Azure DevOps pipelines. I was unsure about putting that one in because really you need to be a big org to even start making the best use out of that. It's a costly one. You will spend a lot of time scratching your head. It's great, but complexity is high on that one.
Also, I mean, at that point, I would be asking why not GitHub Actions. I mean, the back end of the two is basically the same thing. Yeah. Microsoft had the Agile DevOps stuff, which I think they were called the TFS, or what was it, the Team Foundation Service or something. Yeah. I think it's called VST at one point as well. They changed the name 4 times. Anyway, and I think way back in a talk I did, I think I was recommending this at the time, but that was pre-GitHub Actions. So I think if you were looking at that, I'd be encouraging you to take another look at GitHub Actions at that point.
Almost all of these have free tiers where you can experiment. And if you're doing open source, almost all of them will give you a free amount of compute time, which is, in our experience, it's enough to at least get you going. And what's great is all of these offer hooks into GitHub, and in most cases GitLab, except for GitHub Actions is the only one that I don't think you can link to GitLab. But if you link them together, it means that you can directly. So what happens with us is when we do a commit, it automatically starts the CI process. CI is something where once you've used CI, it's almost impossible to go back. It will definitely make your life a lot easier, and it's definitely something to consider.
I think we've got a bit over time on that one, so should we?
Yeah, sure.
Just questions in there. It's really crude option. A mouse keyboard automation framework. Also hotkey. Yeah, maybe, and some. I see how to check the output. Truly crude. Yeah.
The problem you've got with stuff like mouse keyboard automation frameworks is they won't work on CI. You can't guarantee what state CI is going to be in. So one of the problems we have with Ampify Studio is the CI framework is headless and doesn't have a sound card. Also, if, for example, if I write a test that says, that a certain behavior in the interface should work, that test shouldn't fail because somebody changes the layout. If they nudge a button around, or if they move that button 20 pixels to the right, that shouldn't break the interface. Or even if they move it from the top right corner down to the bottom left, the test should still run because that button's still visible. It's still available to the users. The problem with OCR is that or moving the mouse or keyboard to a specific point is super brittle.
I've heard from others who have used this before, because I've always been worried about it for it being so brittle, that in the end it's been a hindrance to them actually in the long run, and that they found that their tests fail so often that that they don't have the confidence in their tests, so they don't really trust when their test fails, and that's really not a position you want to be in. But I do see the point that there's a truly crude option. Just got to be really wary that over the long run, especially as that scales, well, it doesn't scale, and it kind of forces you to not make changes.
Yeah. So I think now it might be good to maybe start talking about TDD and BDD a bit, seeing as we had TDD or BDD.
250. Oh yeah, TDD or BDD, and we had the 244s on TDD in practice and BDD in practice.
Yeah. So I think we'll maybe do a slight comparison, maybe dive in just to see the differences. So let's go to the next thing. So TDD is test-driven development. BDD is behavior-driven development. They share common things. The idea of testing in general is that if you follow this process, you only build the minimum required things. You don't over-engineer, create all these things that you don't actually need, that might have a load of bugs in, that you might come back to later and they don't work. You just do it bit by bit and test as you go. And at the heart of both processes is this write a test, make it work, and then make it even better kind of cycle, which is, as I said, at the heart of both processes. So just to, what we got. One, again, here we go. Here's the it depends answer. They both have their place in a project. I don't know whether you would agree. I would tend to probably prefer BDD, just if you said, which one? But there can be uses of both. We'll see why. I guess I kind of prefer the behavior style. I think it's a bit more. I guess I like the verbosity of it.
I think for us, the further up that testing pyramid you go, the more behavior driven it becomes. So our end-to-end tests, I don't think you could write those as a TDD style test, because they're about testing the behavior that the user can see, the behavior that the user does. At the lowest level, we definitely have TDD style tests, especially for things like, like a JSON parser, for example. Our JSON parser, the way it's tested is very like, when I give you this string, I get back this exact string, or this variable, or,
Yeah, it's sort of, because it's code for other code, whereas like the behavior, it's more about, you're talking about more real life things, like I press a button, whereas deeper down, it's like, I have this object that's going to be used for some real life thing, but we're so far down that, we are just testing
That being said, I think like we've certainly been finding that that just thinking about the like even those low level things, just thinking about them, like you say, from a coder's point of view or something, and thinking about I've got some given state, and then when I do some action, then I expect something, and maybe even there's not when, maybe just like given this thing, then I expect this, and that might even just be the test, and that's made us write the better, more useful tests. It makes it much more. It makes you think about what's your intent. Whereas when you do the TDD, there's nothing really sort of forcing the intent necessarily, and it can lead you down that path of making that mistake of testing implementation just details or kind of covering the same thing in lots of places and it not being clear what the intent of the test was. So we've actually found even just trying to adopt something much more like that BDD, that given when then, even on the low level stuff, most of the time that's where we try and start, and only if it's just it doesn't read right or it doesn't feel right for some reason do we back off.
I think TDD tends to have its place when you're I don't want to say forced to write the code first, but TDD, I tend to end up writing TDD where I'm adding tests to something that's already written for some reason, or I'm trying to refactor something and I'm like, I need to know that I'm not breaking this as I'm going. Whereas new code, I would always favor BDD because I think it's an easier way to write. One problem we've got with Studio is that I think the frameworks that we've built up don't necessarily lend themselves to that kind of BDD style. It definitely lends itself more to a TDD style. And that's something when you're choosing a framework that you need to be aware of what its strengths and weaknesses are. I mean, we started out using the juice test framework, which I'm not sure would be where I would start if I was coming at it again. And when we found that we kind of outgrown the juice test framework, we ended up building our own test framework. And I think now looking back, I mean, it served us well and it worked and we run hundreds of tests every day. But I think I would probably choose one of the big sort of open source frameworks.
I guess we can quickly touch on that. So we've got a slide that has some example frameworks, and I've got some. Then I think it would be good to dive into the two processes. So the frameworks, I think.
Behaviour test framework.
Should we go through the slides quickly? Is that showing?
Yeah, let's come up.
Yeah, cool. So if you're new to this, I guess it might be worth playing with all the major ones really and seeing what works best. As we said, C-test, if you're using CMake, that integrates really nicely. Game of Life, nice. Didn't see that. It's cool. I guess these 4 questions. Is it easy to integrate with your build system? Is it easy to add a new test? Is it what's the word? Are you gonna want to like add a new test? Is it straightforward? Is it suitably lightweight? And I guess what we mean by that is, do you have to sort of wade through all this setup stuff, like making sure things are included, or can you just like do one thing and you're set up and ready to go? We've definitely found things like that, like Catch is so easy to just bring in and start using straight away. And does it provide easy to use tools? I guess what do we mean by that, like mocking tools and
that was the main thing that I was thinking about. It depends on how you write your code, how it's structured. I know a lot of people who are big fans of Google Test, which provides a lot of mocking, stubbing tools. It will do a lot of things for you. Personally, I find that what I want in a test framework is the minimum possible. I want it to provide me with basically a few key things and then to go away and let me figure out the rest of it. But your mileage is going to vary on this stuff. So this is why I think we would suggest build a toy project and actually try all of the test frameworks. So go to Project Euler or build Game of Life. I mean, literally every time I try a new language, I build Game of Life, including some that you should never try and build this kind of stuff in. My colleague Nico actually built Game of Life in Soul, which was an interesting one to see.
Very cool.
But yeah, so I mean, in terms of the frameworks that are out there, the sort of big ones are Catch2, Google Test, and the Juice frameworks.
If you're using Juice.
If you're using Juice, yeah. I've used all of these on commercial projects, and I would say Catch2 would be the one that I would go to every time. It supports TDD, but it's definitely architected in a way that pushes you towards BDD. I would probably be less encouraging people to try the Google Test or the Juice unit tests. Google Test, I think it's too heavy. The Juice unit tests, I don't think are...
It's the other way.
Yeah.
We tried, when we were looking at Catch2, we sort of said, do we really want to put in another dependency? It's quite common in C++. You sort of say, look, let's be careful how many dependencies we put in, right? And we were using Juice. We're like, well, we've already got Juice there. Let's use the Juice unit tests. And we were trying to see if we could just write them in a bit more of a BDD style, and literally just by adding comments, saying like, given, when, then. And it did improve things, but it just wasn't comparable to using Catch2. It just and things like just getting the output and be able to get into things like the JUnit stuff. And there's something about it that just seems to flow a bit nicer with Catch2. There's a couple of things I've done to like improve it slightly for us specifically, but generally speaking, it's really good. I think Phil Nash has done a great job with that, honestly.
Yeah, and in the next session, we can go into talking about our specific experiences with using Catch and testing Juice code specifically, because there's a couple of things we found that that hopefully improves the workflow. Yeah. So I think,
I was just going to say, in terms of sort of other resources, go to YouTube and search for Phil Nash testing and just watch all the videos there. Yeah. There's hours and hours and hours of Phil speaking at conferences and meetups. All of it is eye-opening. All of it is, you're going to learn something from every talk.
Also worth saying, picking the test framework, just the other languages too. I mean, I would say often I would lean on, do a little search around the internet and figure out what's the most common one used within that language. That normally tends to be useful, especially if you've got to do with hiring a team as well, because you need to think about other people coming in and understanding that test framework. Certainly something I'm thinking about when we're picking stuff. I'm thinking, well, what hires have we got coming up? How are they going to integrate with this when they come and join the team? It's all well and good this team's getting on with it, but how's that going to work when a new person comes in?
Yeah, there's mentions of Mocha as well in the chat.
Mocha,
Yes, Mocha. So we use Mocha for our test runner for the end-to-end tests, but we've also used Jest. Big fan of Mocha and Jest. They're both incredibly lightweight, super simple to get your tests up and running. They obviously integrate really well with Node. And they're very simple to use. I know Python has a built-in testing framework, so if you're writing Python type code, if the language provides its own built-in unit testing framework, use that.
That's a good place to start.
Yeah.
We're actually using that. So we write some Python, we use the built-in stuff. I know that some of the web team have moved to a third-party dependency, but that really is when you've got a lot of code, and I think they for a long time are using the built-in one. For most purposes, it's very it's pretty good.
Yeah. We also use Rust for some of our back-end authentication services, and all the testing that are using the Rust built-in framework. It's really good in Rust.
Of course it is.
Testing is like a first. We're using the wrong language. I mean, this was already decided the other day. Jules and Dave convinced us of that one. But yeah.
So I think it might be useful just to quickly run through the different processes, because we keep talking about this TDD and BDD stuff. We mentioned this idea of this type loop of this writing the test, it fails, you then fix it, make it pass, and then you refactor. So I basically just summarise what we're just about to show you, so I probably shouldn't have rushed ahead like that. So here we go.
So step one is you need to write a test of some description. Notice you've written no implementation code here yet. Mm-hmm. So then you want to write some code that works. And the key thing here is that you need to write the minimum amount of code to make that test pass. So, for example, if you're saying that, if your function should return, your test says function returns value over 0, that function could just return 1, the number 1. It doesn't actually have to do any of the computation involved with that test yet. What you've done there is you've written the behavior, you've written the interface part to it. The internals don't matter at this point. So the next step is to clean up and refactor your code. So in getting that working, you may not have written particularly clean code. And in terms of clean code, just because I totally love this book, Robert Martin, Clean Code, Uncle Bob. Again, go to YouTube, search for Robert Martin Clean Code.
Great talks. There's
some amazing talks. This workshop isn't really about clean code, but the intersection between clean code and testing, there's a big overlap. The cleaner your code, the easier it is to test. So yeah, definitely recommend watching some of Robert Martin's talks. So once you've cleaned up your code, you're then in the position that you either need to go on and write another test, and in which case you're now in that loop where you're kind of going round and round. You write a test, you make it pass, and then you clean up and refactor your code, and you keep going round and round. Or you've actually finished the feature, and in which case you go and you step out, and at that point you just need to make it run in CI, and hopefully that's it. You can give it to your product owner, your manager, your customers, and you're kind of finished. So we actually had a bit of code to kind of demonstrate this.
I just wanted to jump on something like that. Just also there can be slightly different styles for different people. So some people really like to make sure that when they write that test in the first place, like that's all they're writing is that test. And I know I quite like it that, so they'll say that the first failure is it doesn't compile, right? Like, I have this temptation. I really like to say, no, I really do. I just need it to compile. I want that class name. I just want a function. And like you say, like the return type are almost always, if it's got a return value, just do like open close brace or something to just do the default value in return. But for me, I really like to have, I just need to make that file, add it to the CMake or whatever, and just start having a class. It doesn't really have to do anything, but I need it first for me. Otherwise, I can't really get going.
Yeah, I think for Studio, quite often we do that same thing, partly because a compile of a new file can take a long time. Yeah. I mean, we're talking like 4 or 5 minutes to get that working. Once you've written it the first time, the subsequent compiles are much quicker. Yeah. But yeah, I'll usually hit build pretty early on because I want to know that it's So this little example that we've got on the next slide. So this is taken again from that talk by Dave Stephan, Scientific Unit Tests, and this is to show one of the problems with test-driven development. So, for example, in this example, we've got a cup, and we want to test it. So, by definition, the cup should be empty when it's constructed. Okay, so we go, let's write our test. So our test case is we construct a cup. Okay, so we create a cup. Now, how do we test that? The problem is that you write, well, we require that the test is empty, that the cup is empty. But you can see we've already got a dependency on 2 different parts of cup here. So we're having to call is empty and assume that is empty returns the right value. But okay, let's assume that that's okay. This test passes. So we go, okay, the cup's empty. then we go, okay, well, now we need to test the isEmpty function because this is TDD, and TDD is about testing the whole interface as code. So then we write a function that's called isEmptyWorks. And the problem is here is we've written the same function, or the same test again. So we've got two tests that are identical, that are testing different things. You shouldn't have two tests that are testing, testing in that way. So yeah, the question is, isn't this the same code that I've already written? Are we going to jump into BDD?
Yeah, go for it.
Yeah, let's keep going. I think it's BDD. I think the three topics were all really high. So
yeah. So somebody else want to take this? I feel like I've been talking for a while at this point.
Yeah, sure.
Go for it.
Yeah, BDD. So as we've said, it promotes only testing that public interface rather than all these implementation details. And yeah, I think I mentioned earlier the sort of test being the client of the code, which indeed might be the customer. It might be as simple as, when the user presses a button. Might not always be the user, but it's just this idea that it is a user coming to this code, and that is what you're testing. The idea, this is partly to do with abstracting away the implementation detail, is you're just defining how the software is to behave, but not actually how it's done. It's not saying, okay, when I do this, it needs to go off and set this thing and then, set this thing. You're just saying, when I do this, this thing changes from, and you ascertain that from the public interface from your class. It's this idea that you're going from the outside in, because you only really know about the interface. You don't know how the thing is carried out.
TDD sometimes is called inside out testing because you're testing based on knowledge you may have about the implementation. Exactly. I think that the cup one is a great example of that. You have to know how isEmpty is working in order to be able to write those two tests, which is why you end up with that kind of cross test, as it were.
Yeah, so the cycle goes, you describe the expected behavior, you write a test that expresses that expected behavior, and it fails. This is similar to TDD, so it fails to begin with, and then you write the code to make the test pass. This might be the simplest code that does it, but you make it pass, and then you have the option to clean and refactor that code like before, and you're either done or you carry on that cycle. So I think we've got an example.
If we keep going on, I think that's the next one.
So we've got our cup. Me and Anthony had quite a long discussion about this. We're like, is it a cup? Is it a drink? Like, we got down into quite a ontological rabbit hole. But anyway, got the cup. So how would that look with BDD? So we have specified that a cup is empty by default. So if we consider that, so we say our scenario. So with BDD, you generally have a scenario, which is the thing you are, the overall thing that you are testing. And then we'll go into the other keywords, which are the given, the when, and then the then. So to start with, we say, given a cup. And we, make a cup. And then we say the specific thing we want to test, which is then when we have a new cup, the new cup is empty. So
I think the important thing to point here is this is a good example of the when is almost optional, right? It's like there's no action here. Mm-hmm. You don't need to invent an action. You don't need to insert a when. You can just say, given a new cup, then the cup is empty. Mm-hmm. And when I write these, I often like to just stop and just think, how is that going to read to a human in general, right? Scenario, a new cup is empty. Given a new cup, then the cup is empty. Yeah, this reads perfectly. So if I fail on that require, I'm like, okay, it's telling me that the cup is not empty when I have a new one. Yeah. Like it might sound like a simple example, but that really is what it's like when you're writing these tests.
And this goes back to when you're we work in a agile fashion in this team, and we use Scrum as our agile framework, and part of that is we do refinement on user features. So if the user feature is, I want to add a filter, we'll break that down into a set of specifications. So it will be, a filter set at 100% is at 18 kilohertz. So that can very directly be translated into a behavior-driven example, because you can just say, given a filter, given a filter when cutoff is at 100%, then frequency is at whatever, 18 kilohertz. And it very directly will translate into the behavior-driven development style, whereas it's much harder to turn that into a TDD style.
Yeah. The only thing I'd note about that one is when you've got the thing we've been finding, when you've got numbers in the given, when, then, is just watching out. Sometimes you find yourself going, well, I'm going to use this number because for some reason it's the test case I want to do. And then you tempt yourself into saying, well, given when this is 5, then this, I've only got to multiply by 2, then this is 10. And actually, I've been finding that often you just need to think about what the intent of what you're testing is. Were you actually testing 5, or were you testing for values greater than 1 or something? Like, for positive integers or for negative integers. Like you often want to write your tests as the naming should be like, for, given a positive integer, when I do this thing, then I expect this. And the values you actually use for it are almost irrelevant. But sometimes they're relevant. Like in that case, I think that 100% and then coming out for a frequency, I think the values are actually very relevant.
Yeah. So I guess it's all about just saying what is the thing that is changing. So we've got some, let me just see what we've got here. So there's some tips on writing each of the sections. So as I said, the scenario describes the intended behavior of the feature without saying any specific kind of values or implementation detail. It's just saying, what is the feature? You then say just a bit more on the what, not the how, as I said. So an example, it depends on, this idea of the scenario being this sort of high level kind of end goal. If I make this show up, so if we read through the one on the left, we say that the given a new cup, then the cup is empty. So that's great and all, because that's maybe what we wanted to do in the first place. But say later on, it's actually we've got this cup because we want to make a drink. We don't just want to have a cup for the sake of having a cup. You might find that, and I don't know if this ever happened for you, but the actual scenario kind of changes, because once you've moved to like actually wanting the feature that you want some software or whatever. This is just a silly real world example, but the end goal is making a drink, and you do that by having a cup. That might not always be the case. You might have some different object. You might have a carafe or wine glass, depending on how the day has gone. So you can so the scenario is now changed to make a drink, and then you say given the new cup, and then like before you put the same thing. So then the cup is empty, but you can then extend that with the when, and say when I add liquid or add water. So there's another example of abstraction here. We've got when a liquid is added, how you go about doing that is an implementation thing that you're sort of documenting that here. So you're saying, to add liquid, I do .add water. So someone coming back to reading the test says, I see. To make the drink, you add the liquid, and to do that, I need to call this bit of code. And then you say, of course, to test that, then the cup is not empty. So it's just thinking about how these things can slightly change depending on the sort of end goal of the feature. Should we quickly, what's the time? We've got 10 to. I was wondering whether to do a quick comparison of TDD, BDD, just to sort of wrap up.
While you're finding that out,
yeah.
So Martin asked the question, should tests be written with a view to expect to change your framework? I'd love to say yes, but once you're deeply invested in a testing framework, you're unlikely to change, which is why I would really encourage you to try as many as you can before you make a decision. I would love to replace our testing framework with Catch 2. The reality is that if we want to do that, it would be a case of saying, okay, all tests in the future will be written with Catch 2. If you go into a test, then you should rewrite it in Catch 2, which goes with, I think, going back to the clean code thing, we have one of the things that I encourage everybody that I work with, like all my teams, to do is to, that if you touch code, you leave it better than before. If that means that you end up rewriting a whole class, a whole module, then so be it. Because you've got to keep maintaining your software.
Yeah.
And I think that it would be the same with tests, that we would say, if you touch a test, make it Catch 2. But, you know, it would be hard moving forward there is absolutely no way that we could replace thousands of unit tests and hundreds of integration and end-to-end tests in one go, because part of the problem is that there's no user value for that.
Yeah.
So because of the way we work, everything has to have user value. There's no user value in just doing a purely technical task for the sake of it.
I think we've done exactly that. So we started off with juice unit test. It wasn't too long before we went, no, Catch 2 is the right thing for us.
So we've still got we've got a handful of juice unit tests. We are running both, and I guess that's okay, as long as you are running them. Obviously, you'd want to sort of deprecate, using one. So obviously, as Paul said, if you touch one, make it the new thing if you can. So yeah, we do have a handful of juice unit tests still, but there was a point where we said, okay, we're going to add Catch 2. So from now on, we write, just the Catch test.
Catch 2.
I mean, if we go, like we said, if you go back to that code and you're in there, you're just going to change it. Especially if you're like, I'm adding some new line of code or something here, and I need a test. You're like, well, it needs to be Catch 2, so I'm going to have to convert all this to Catch 2. And that's just what we do, and we just accept that.
Yeah.
I'd say in general, with that whole framework thing, be really careful of thinking about, like, what if I change framework? I've seen it happen before in code bases, and it caused a lot of bloat, where you just effectively write another framework yourself over the top to try and prevent it. It's riddled with all sorts of issues, unfortunately.
Yeah.
So the one caveat to that is, if you are, I'm not going to say lucky enough to write in JavaScript or TypeScript, but if you write in JavaScript or TypeScript, moving from Mocha to Jest would probably take you an afternoon.
Right.
They are so close together. And it's one of the reasons that I really like both of those frameworks is they're in the same style. I don't think they're actually related, but they've clearly been influenced by each other. I might be wrong about that. Somebody who knows JavaScript better can probably tell me. But you can move between those two frameworks very easily.
It does touch on one other point as well, which is that you might think, like if I just wrap this up in like functions and stuff over here, and actually I find you want to, where in normal production code, I'm often like DIY. Don't repeat yourself. Actually, sometimes when it comes to the test, I'm a bit more what you call better, like write everything twice, because you want to make sure that it reads the same way that someone would actually use it in real code. Like they're going to have to make this object and they're going to do this thing. And you feel like, I'm just going to wrap that up in some other thing over here. If that's not how you would actually use that class or whatever it is you're testing in the real thing, then I don't think that's very nice, because that removes the documentation aspect of it, and you find yourself having to go through layers and start to understand the test, and you don't want that.
Yeah. As a caveat to that, the one place we do that is we use a lot of fixtures.
Yeah.
So for example, say we're testing, like a class that needs a lot of other dependencies, and we've mocked or stubbed all those dependencies. We will quite often shove all of that lot into a fixture. And then we can just access them all directly. But the key thing here is they're not actually the things we're testing. Yes. They're the things we need to make the tests run. The class that we're testing will be created each time. Mm-hmm. So
So I think just to wrap up, I think we should take a break shortly. But as we've said, I think they both have their place. I think if you're new to this, I would strongly recommend playing around with writing BDD style tests and seeing how you get on with that, because I do like the sort of.
I think when you were first writing, that was really what hit home for you and made it easier for you to write tests when you started, right? I think we had GTest we had the Google test stuff, and I think it's just harder to get your head around. There's so much bloat around it, and it doesn't really encourage that BDD. Mm-hmm. And one of the reasons we switched to Catch 2 was just how much it sort of pushes that direction. It helps us write tests. It makes it easier to write.
The other thing about Catch 2, and again, I know I referred to Phil Nash's talks earlier, there's so much resource on the internet. If you go to YouTube, search for Catch 2 testing, there's so many great videos. One of the things, I mean, this total aside, one of the things that I really like doing is while I'm doing the washing up, I'll put on a conference talk on testing or a conference talk on structuring code. And I'm listening to it in the same way that, my wife, when she's doing it, she has the Archers on the radio. Not really listening, but it kind of seeps into your brain, especially if you do it regularly. Just have that information kind of seep in. When you're stuck on a problem, go and watch a conference talk. It will inspire you. It will give you ideas.
CPPCon's got some brilliant ones, and CPP on C as well.
So shall we start, given Graham's question about testing an audio file, should we start with testing DSP? Yeah. Seems like it would be
go for it.
Kind of related. So let's see. Yeah, it's hard. Okay, we're going to caveat this whole section with that. Testing DSP code is really, really hard. We struggle with how is best to test DSP as well. I think there's a few things to sort of caveat here. So DSP code is a big field. If you're talking about envelopes, LFOs, sequencer engines which generate events, those are actually much easier to test because you're generally talking about a much lower amount of data coming out of them. You can generally compare them to expected results. For event generators, so for an arpeggiator, you could hook the output and make sure that you're getting events at the expected time code. We do that in our sequencer engine. For true DSP, so things that I would put in that category are things like filters. I think I would start to approach it as a mathematical process. The likelihood is for those kind of bits of code, you've probably you're either copying from some sort of formal proof, or you've created some sort of mathematical version of it. And in which case you can directly reference that as the mathematical proof. And you can always test for out of range, nans, infinites, stuff like that.
If there is some like specific reference you've used to do it, I know something we've had in the past, one of the times we'll add a comment in maybe, is to just make sure that there's a link to say, here's where we got the reference for how we're determining this particular algorithm.
Yes, so we do the same. We tend to use the GitHub. There's like a wiki section on GitHub. We tend to include, just because links go stale. So we tend to include it in our GitHub page. So like, for example, in Studios, we have all of the Launchpad manuals, which we reference for the MIDI implementation. They're all stored in there. To go to Graham's actual question was, if you have a test where the expectation is an audio file, how do you approach audio output which is not bit exact to the expectation, but it is acceptable to human ear? So if you refer back to the 7 aspects of a good test, One of those is that it's consistent. And the problem with doing bit comparisons between audio files or even comparing audio data is that's super brittle. You know, say, for example, you decide you need an extra range of precision, so you go from float to double. You're going to end up with something different, even though, as you described, that's totally acceptable to the human ear. The difference between those files is a semantic difference. It's not a failure in the code.
In saying one thing we did when I was working at Sonox was we'd have to port, say we'd have some native implementation of DSP and we'd port it to some other chip. And we knew that we had to make, you know, some changes in the way we're calculating something. Maybe something could be done natively very easily and we'd have to do some sort of lookup table or something. And there's some loss of precision in there, right? So, but we knew that to the human ear, like being suggested, that it's totally fine. One thing we did was we just set a specification. So we normally start with a specification that says something like, you know, this port must cancel down to minus 50 dB or something. And then we could just be sure that once you just took the two signals with the same input, you inverted one and you've done it, you just have to say that no sample ever exceeds some particular value. Yeah. It's still tricky though. Take something like a compressor and, you know, the way in which it reacts, it could be samples that come through and come above that. Yeah, I mean, as it says at the beginning, it is hard and it can be very dependent and it does tend to make brittle tests, quite frankly.
Yeah. In terms of the null audio test, I mean, that applies to floating point numbers in general. You want to always be comparing them to some epsilon value. Whatever, like in your code, if you're going through your tests and you see something like, if my float variable equals 1.579, then you're very, very soon going to hit that as a failure case. You really want to be using, so if you do the abs of those two numbers subtracted and then compare that to an epsilon value, that will give you roughly the right idea. If you dig deeper into the representation of floating point numbers, you'll often find that people recommend not doing that. In my experience, it's all right until you really need a lot of precision.
And Catch has tools for testing floats, so you can do the approx stuff, and there's different ways of testing the different there's different types of varying the comparisons. You've got like the margin, the scale, and the epsilon, right? So there's different ways of saying, okay, I want it to be, you know, maximum, you know, 50% out, or I want it to be no more than 0.5 out if you want to be exact, or, you know, things like that. But I feel like the epsilon thing's probably the best generally.
Yeah. I think we had a case, right? I mean, it wasn't quite a DSP, but we had a case of preparing for these slides where we took a tool that was measuring latency. And in fact, once we wrapped some tests around it, we saw that it wasn't quite working. But when we went back to the engineers, it was like, well, actually, it turns out that the algorithm, you know, give or take 5 samples can measure latency within a system, so round trip latency this is. And then it was agreed that, well, actually 5 samples, even at 44K, was less time than it takes for a USB microframe. So actually, we were happy with that. And so we just had to encode that in our tests and say that we were allowed a margin of error of 5 samples either side. So that is a way that you can start to deal with that.
Yeah, and that becomes part of the documentation of that tool itself. So we had a few sort of examples of what we might want to do here. So don't try compiling any of these, because I don't think they'll actually form like a proper A and B for a biquad. They're close, but not exact. But, you know, the point here is that you've got a function that returns some structure to represent something within your DSP. You know, and that will likely be based on something, you know, provable. Hang on a second. So we know what the transform in this low pass filter should be doing. So we can write, why has that not switched? Let's try that. Nope.
I can click it on here.
Let's try that. There we go. I've got some code. So in here, we're actually, we're using the scenario given when then to actually confirm that the values we're getting out of the biquad are sensible and that they're in the required ranges. Now, there's an argument that what I wrote there is not really BDD because you're having to understand something about the internals. But I think this test still has value because if somebody goes in and goes, oh, that doesn't look quite right, the Q should just be Q, or it should be 2 divided by Q, or they go in to fix something because they think there's a bug, the test has defined that, no, the expected behavior was this. When I wrote it, I intended it to be that. So, you can test in that way. And, it's likely, again, for something like a biquad, you're probably basing it on a paper that somebody's published. Mm-hmm. There's probably known A's and B's that you can compare to. So
I think you can make those const.
The poll is covering the slide.
That's a good point. What? You make those constant. Q in your game.
Oh, yeah. Make everything const, kids.
I guess the other thing to point out here.
Graham says the poll is covering the slides. Can we dismiss
okay. I do apologise.
The poll is covering the slide. You should be able to close the poll. I don't think I'm sharing the answers currently.
Right. Maybe if you share results, then they can close it. Maybe.
I think I'd already shared them and then ended it. Let me just see.
Graham says that was resolved.
Sorry about that.
Sorry.
Okay. Apologies for that.
Cool.
So then the other thing that I mentioned earlier was about testing your process call. Now, again, like normally you wouldn't write a process call that has just a single input and output, but for the purposes of this, just to show what I was meaning, you can test it in the sense of pushing values in and making sure that the result you get out is within a certain range. So you see here we've got an outer counter. We've got an outer counter that's running over the wends. We're then processing the filter. So what this is doing actually is pushing in a number between -1 and +1 into the filter to represent the audio range. And we're just checking that all the numbers that come out of it are not nans, they're not imps, and they're in the expected audio range. Mm-hmm. This kind of test you can write for any piece of DSP. Any well-behaved piece of DSP shouldn't go nan, shouldn't go imp, shouldn't go out of range.
Yeah.
Unless you're doing something very peculiar, and in which case, you would know that.
Yeah. Yeah.
Cool. I didn't know about the is-imp. That's really cool.
So the one thing I would say about is-inf and is-nan. Mm-hmm. So is-nan, the definition of a nan floating point number is that you compare it to itself, and it doesn't compare the same. Yeah. So x is not equal to x.
Right.
The problem is that if you actually put that in a type loop inside DSP, you'll A, blow your CPU out, and B, it'll blow the cache. Right. So what actually happens is if you put is-nan inside DSP code, the code just slows down to the point of you can't actually use it anymore.
Right.
But for tests, it's amazing. And one of the things that I've done in DSP code before, especially where you have that classic problem where a user reports, if you do this with the filter, I get and it dies. If you put in a bit of code with is-nan and then just do that, and you don't necessarily need to hear it, but the moment you hit that, you can then go in and look at the filter coefficients, but you need to take it out. You can't ship code with is-nan and is-inf checks because they're too costly. Generally speaking, DSP code really, really hard to test. Try and treat it as maths, and try and approach it where you can using the formal proof. Try to remember not to make it too brittle. try to do epsilon ranges when you're comparing audio. One thing that we've done is you're testing, if you test the general output of it, so if you're testing the output of the filter, potentially you can, if you feed it white noise, and then you take the, you do your Fourier transform in the output, you can look at what frequency bins you get and whether you get a flat response, in which case the filter's not done anything. You know, if your cutoff is at 2K and you haven't got any signal above 600 hertz, you know, something's gone wrong. You know, your tests can be, it goes back to, you know, you want pragmatic tests and tests that are going to be runnable in the future. So test for the really obvious things where if they fail, you know.
I think also it's all about that, trying to break down to the units. So you might have some DSP and it's really unique or whatever, but generally speaking, that's going to be built up a bunch of components, you know, known simple components. And it's just about understanding, fully understanding the specifications that define what that thing is, and understanding, oh, that means when I have an input of X, that means I will get Y, and trying to encode that as much as possible. Like we've done a similar thing. It kind of goes in similar thing of like testing colors, like testing like contrast of colors. So we have tests in our code where if a designer comes in and says, hey, I want to change the color of this, we've got a contrast checker that basically says, hold on, you just broke contrast for this button over here because now the foreground color is not got good enough contrast to the background color. And I think it's a similar thing. It's like understanding like the point is that this foreground color over this background color must have at least this contrast. I'm not testing anything particularly exact. I'm just saying there's some specification that I'm able to test against.
Yeah.
I think you can certainly sometimes do the same thing with DSP, but it's hard, it's tricky.
So Joe says, if DSP is very creative or non-standard, it could be considered content as you would an image, then it probably doesn't need to be tested.
Yes, yeah, that's true, yeah.
And I think it's that drives totally to the pragmatic thing. It's like you have to understand what it is you're testing and where you can apply those tests for the best effect.
Yeah, I think it might be good to cover the human aspect at this point. I think we had a question earlier.
Yeah, that section is very short, isn't it?
Yeah, so we could just quickly, where was that?
Somewhere up here. So yeah, I mean, while we're finding these slides, essentially humans being involved in the test process. So traditionally, at least for a sizable chunk of my career, you know, an engineer would build some code, would give it to a QA tester who would then proceed to poke and prod it and make sure that it didn't blow up. And you know, it's very, very inefficient to do that. So this is a quote from Dave Cheney that I really liked. Yeah, manual testing is order N. It's slow, it's error prone. We can automate all of this stuff, and you know, that's a better use of time. And then what your QA gives you is that human perspective, the thing that your tests can't pick up. So one of the things that came up just this week was the aspect of, you know, we were testing a filter, and Oscar pointed out that, you know, when you use it from a launch pad and you press this button and you press this button, it jumps instantaneously. Well, that was what the specification says, and that's exactly as we wanted it to be. And the filter didn't blow up, it didn't respond incorrectly. But he pointed out that no musician wants it to do that. They want it to glide. You know, that's something that a test can't understand that. You need a musician's input to be able to understand that. And that's where the manual testing comes in. So what your manual testers is looking for is where you've made errors of judgment in the interface design, in the usability and the user experience. If they do find bugs though, that better be the last time that bug comes up, because you should write a test that reproduces that bug and then it won't happen again.
Well, in that particular instance, how did you go about writing a test to capture that one to make sure it glides in future?
Well, we wouldn't, because I wouldn't consider that a bug necessarily. I'd consider that to be a usability feature. And as it was, it's an interesting one, because that's one where we took it to our sprint review, and Oscar raised it and said, this is a debatable point. Should it jump or should it glide? And if it glides, how long should it take? That's not something we thought of when designing the feature, but it opens it out. And, we had loads of great input from people in our sprint review where it was, should it be based on how hard you hit the pad? Maybe the harder you hit it, the quicker it jumps. Maybe it could be a button on the user interface. But that's not, I wouldn't consider it a bug per se, where, a bug to me is like when I click the filter here, it crashes the app, or something along those lines. They're the kind of things where you can definitely write a test, and then there's plenty of things that Oscar finds where it's like we have made mistakes, but we can very easily write tests around those things.
Cool. I think we just run out of time on that one, actually.
Yeah, cool.
So we'll move on to another.
Should we talk about async stuff?
I think that was on the top there, wasn't it? One of the options. It could be a good one.
Yeah, I think you guys were going to...
Yeah, I think we've got a little bit more on this one. So
testing asynchronous code. Cool.
Yeah, sure. I guess the first thing is, again, like it can be quite hard, but I think there's it's tricky when you need to wait for some event to happen. And I think first of all, there's two kind of instances where you get asynchronous. There's one where you call a function and it's going to do something, but it's not going to do it immediately. It's going to do it at some point in the future. And so you're there going, well, I've called this function and I want to test some state, but you don't know when to test that state, because if you test it immediately, it might not be the case yet. It might be that it's going to happen at some point in the future. So how do you test that? And then the second one is that you need to call something, but currently, let's say the thread you're on in the test framework you're in, it needs to happen on some other thread, and then you need to wait for that thing to happen before you can continue. So the latter one. It's got examples. For example, a thread needs to complete some task. I guess that's it passed off somewhere, and then you've got you need to test a callback made using the message manager call async. So that's when you've got something that wants to run. That second one, the message manager one, is you've got something that needs to run on the juice message thread, for example. So in our case, for Catch 2, all of Catch 2 runs on it's got its own thread it runs on. And so sometimes there's functions, you call something in juice, you set the text or something, and you'll get an assert saying, hey, like this needs to be on the message thread, the message manager needs to be locked to do this. So the way we deal with this is we could probably show the code in a bit, but we basically have a function that you pass it in a lambda, and it will go off, call this message manager, call async, to go and run it on the other message thread. And then it will sit there and wait for that function to be called. If the function you called throws an exception, it basically captures the exception on the other thread and refrows it on the current thread. So it basically turns what is an asynchronous call into a synchronous one. And so that one is kind of solvable. I thought I saw a question come up there, but it just disappeared. The other one, where you call some function and then it needs to, it's going to go off and do something asynchronously, and you don't know when it's going to happen. That one I think is slightly harder. And the way we've normally dealt with it, and we definitely have this quite a lot for us, a lot because we're dealing with hardware, that sometimes these things do need to go off and be done asynchronously, and also for speed purposes. We have tools we write that get used in the factory, and the speed at which it needs to move through the factory it like the seconds count. And they really do make a difference when you've got lots and lots of units going through. So we want all these like sets to happen on the device, but we also want it to act. We want it to act synchronously, but we want to give this sort of asynchronous feel, so it's as fast as it can possibly be. And what we normally do for the test there it's about defining like your failure states, like understanding what the contract is. And we basically say there's some limit that no matter, it's about that embarrassing thing. It's like there's some limit at which if it hadn't happened by this point in time, that on any machine, whatever it was, that in itself would be embarrassing. That wouldn't be good enough. And so it's just defining that specification. And what we normally do in that instance is we basically we'd have a mock or a stub that's going to have something called back. So we can call a set, we're going to have something that's going to get triggered by that thing. And we would set some kind of promise in the future so that we could then wait on it and say, I'll wait on this for 100 milliseconds or something. And that's the maximum time. If it ever exceeds that, well, then we've broken our contract. That was too long. That was embarrassing. And then the only other thing you have to watch out for there is, let's say you've set your time to 1 second. And actually it's getting through and it's working on your tests, but it's always waiting for 990 plus milliseconds, which is still on that edge of embarrassing. That's probably not right. The thing we just got to try and watch out for there is to have things like you mentioned earlier, having the timeout on your tests. So you've got a limit for the whole of your tests. Like what's the maximum time that should ever run in total, and just watching for that time creeping up and going, hold on, all of our test time has suddenly started to shoot up. What's going on there? Have we affected something? So it's hard again, but I'd still say it's possible. I think I've definitely seen people say, well, I can't test this, it's asynchronous. And I think the key thing to take away is that even when it's hard, there's normally something you can do. There's normally something you can put in place. I think.
Should we show some?
Yeah, I think we should show some code. I think we put. First, consider if you can make the code synchronously using stubbing and mocking and replacing internals. I think it's something. Did you put this?
Yeah. So that's something that we've done in places. Is if it's something that say your code fires off a thread, and you have to wait for that to come. Do you actually need it to be running from a thread, or could you pull the internals of that out and test the internals? Do you actually need it to, if it's a bit of code which calls out to a server, and then when the server response comes back, it comes back to you. Well, do you actually need that server call to be asynchronous, or could you replace that server call with something that just returns a value straight away?
Yeah.
But there's cases where you just can't do that.
Yeah.
The async one, where it's message manager called async, is the classic one. We run our tests on the main thread. So you can't wait on message manager calling async because you're on that thread.
Yeah.
So you're stuck. The question is then how do you call back? And the way we solved it was we wrote our own test framework around it to let us do asynchronous tests, which are very, very verbose. So every test case you want, every scenario is its own class. You have to inherit from a test runner. You then basically call pass or fail at any point, and that's fine. And it has a timeout and all the rest of it. But it means that, for code that's complex and where you need lots of tests, you end up with all these classes all down, and then there's the static constructors for them. There's a lot of boilerplate involved. So we can do it, but it's not nice.
So the way we got around that, and I think this is probably why we share the code, we created like a juice application that is inherits from the juice application base, and then as it starts up a thread and it runs catch 2 on another thread, and then as soon as it runs catch 2, takes the return value, sets the application return value to that value, and then it just quits the application. So it's just going through, running it and quitting it.
Should we share?
Yeah, let's share it. The key here is that because we're running it on another thread, we can now do that whole thing of where we're not on that main message thread, so we can actually have other stuff happen. But of course, the problem at that point is then we're not on the main message thread, so we need to call functions that do need to be on the main message thread. So we, and this is the function we created.
You might need to make that a bit bigger.
Yeah, maybe zoom in on that a little bit. So like in this example, this is basically an invoke function that we run inside of some of our tests. It takes another function, so if we're normally passing some kind of lambda or something straight to it, and you can see we've got two things. We've got a waitable event, so this is like Juice's equivalent to having like a future promise kind of style thing. It's something that you can signal from some other thread and wait on it on a different thread. And then we've got this stood exception pointer, and this is basically what we're going to use to like be able to catch exceptions and rethrow them back on the thread we really want them. In fact, there's an interesting thing where we got tests around this where we actually caught a problem in the implementation of this function. Our tests caught it. And then we create another lambda that's capturing the first one we passed in. And you can see that all we're doing is we're running that function that was given to us, but we're making sure that we catch any exceptions from it. And then we store them in that exception object. And after we've done that, so whether the function runs successfully or it didn't run successfully, we signal the waitable event. But that's just the implementation of the function. We're actually running it at that point. So on the line where it does the if and it calls juice message manager call async, we're passing that call back in. And call async, it should tell us whether it's going to run it or not. So it will return and say, oh, sorry, there's already been a quit event added, or basically the message manager isn't there. And at that point, we just and we just say, hey, like maybe you got something wrong here. That's like a really like something's gone very, very wrong. If that's happened, we should never hit that scenario. But assuming it's been posted onto the message thread, then we just wait on that waitable event, the completed event, and as soon as that's finished, the only other thing to do there is just check whether there was an exception that we need to rethrow the exception. So then at that point, if you've left that invoke, once it's been invoked, you know that the function has been run
on the message thread.
On the message thread.
Yeah.
And even if it threw an exception, it's now just thrown an exception in your test, and catch2 will pick up that exception and tell you, hey, you failed, you throw an exception. And I think we've got, if you look at the Focusrite message manager tests, there's actually a bit of wording I noticed that could be a bit better in this. I need to go and refactor slightly. But we wrote these tests. So I wrote like you got like given, the juice message manager, when a function is invoked on the message manager thread, there's basically just a struct up there that just checks that the message manager exists, that the message manager is, whether it's locked or not, and whether the current thread that this thing's on, whether it's that. And it just, as you construct that object, it just it's the default constructor for each of those members. And so we do a test to make sure we just got some requires there, just to make sure that the default state is that's not the case right now. And then afterwards we call you can see that on line 25 we've got the require false, that it doesn't have a value, got stood optional. So we make a function there, and all we're doing is we're just setting some value function info to an instance of this struct, and we check that it doesn't have a value initially, so we haven't actually run the function at that point, and we call the Focusrite message manager invoke to run the function, and then we go and check that yes, now it does have a value, and yes, it exists, and it's locked, and it's running on the current thread, because that happened on the message thread. And the bit that we caught was further down. I've got the when a function that throws an exception is invoked on the message manager thread, and it says then an exception is thrown on the current thread. Now the exception was being thrown, but the bit I caught was the then froze as. I actually wasn't making sure it threw the right exception back again. And I was a misunderstanding of the standard library. And it's a good example of how important your tests are. Because it would have been later on, some tests would have failed. And we would have been like, well, why is it? I'm sure I've written the code correctly. And actually it was this that would have been wrong. Yeah. And it's a good example of how tests can catch stuff that maybe you hadn't. You think you've tested, you think you've got it right, but actually haven't. And it's not a lot of code. It's been it's early days for us doing this. We've got another class we've wrapped around the top of this for helping with components, because when we're testing accessibility, that you have to do like add to desktop for each component. So we've kind of made a little class to help us wrap that stuff up, because that's the stuff that you don't want to show in a test. You don't want to be like add to desktop, because that's not how you would use that component. It's like it's not of interest to the test. It's not about your intent. But often we want to check that it's got certain accessibility things on the component and say, hey, we want to make sure it's got this, you know, it has actually got some description and it's got, you know, whatever it is. But yeah, it's early days for us. We'll see how it pans out, but so far it's working quite well, and it's allowing us to do more tests than we could when we were just running catch 2 on the juice message thread.
Yeah. I was just wondering whether there's some more slides on that particularly. I might just share that quickly. Yeah, I guess just to delve a little bit deeper into why we kind of need that. We mentioned accessibility. We've got some fairly simple tests. There's nothing sort of major in terms of accessibility. We've just got some basic tests that's just checking, you know, when we've made a component, does it have some accessibility text? That's not necessarily, and what I mean by that with an accessibility text is when we announce this component to a screen reader, will it appear as having text? We're not going down the route of testing the actual text, because that is more of a, that's a sort of higher level thing that we need to just check and remember to do. But it's mainly just a thing to check if we refactor, are we going to, for some reason, remove the text or something? So we're just checking that, you know, it has some text. In order to do that, the component has to have a component peer, which can only happen when it's added to the desktop, right? So that's why we have to sort of wrap that up in order to, do it as in a test as part of a test framework.
Yeah, and it's something that you shouldn't really have to dive into. It's doing details in a test that are irrelevant to the thing you're testing. It's like, I only have to do this because I'm in a test environment, because I don't have the whole GUI made up and I've just tested one component in isolation. The only way for me to get this information is it has to be added to desktop. And the other thing is that add to desktop has to happen on the message thread. And then on top of that, you have to make sure you've destructed the object on the message thread as well. So you have to like construct it, add to desktop, and destruct it on the message thread. And that was making our test look quite gnarly. So we basically made a templated class that you can say, hey, here's the component I want to test, and then you can pull out of it. You can say, hey, I want to get the component back out of that now, and it will construct it, add it to desktop on the message thread, and then at the end, when it destructs it, will actually destruct it on the message thread and wait for it to be destructed before the destructor returns. And yeah, it's certainly making our tests a little bit easier. And then allowing us to do tests that I think we would only really be able to do with a more end-to-end testy environment. So it's allowed us to do more stuff that's closer to the kind of unit test style, just to get that, you know, going back to that triangle, trying to get that coverage, because it can be hard with GUIs as well, I think. Like, it's really easy to get a situation where, like, I really want to test this, but actually it's really difficult. The framework's putting some pains in the way.
So testing plugins, we've kind of made an assumption here that a lot of people on this or in this workshop probably are developing audio plugins. One of the kind of real benefits of working on Ampify Studio is that it's not a plugin. I spent 15 years writing plugins and dealing with the oddities of the way that hosts interact with plugins. So yeah, testing plugins becomes really hard because of the amount of sort of hosts you've got to run in, number one, and because all of the plugin specs are pretty badly defined. There's gaps all over them. So first bit of advice I would give you is pick your hosts. And I would recommend you just pick the top hosts. So by that, I mean Pro Tools, Cubase, Ableton, Logic. Have I missed anything?
I think they're the big ones. I mean,
Studio One. I wouldn't even bother testing Reaper, to be honest.
Really?
But Reaper's a good one only because it's so configurable. So it does allow you to simulate a lot of other doors in all sorts of ways.
The problem with Reaper that I have is to get around a whole bunch of problems in the VST spec. They have all their own VST codec extensions, which because we support loads of them. you wouldn't see issues that would only come up later on.
I think Personas have got the same thing. FL Studio, I think, has a bunch of extensions nowadays as well.
FL Studio, interestingly, is one that's worth looking at in just purely in terms of numbers. Everybody thinks about, I've got to make sure I test in Ableton. The number of users who use FL Studio or some variant thereof, one of their versions, is absolutely massive. Even if you're not an FL Studio user, even if you don't like FL, it's definitely one that I would add to the list to make sure you at least try it. But we already covered that manual testing is a waste of everybody's time. It's ON. So I guess first thing that we would talk about here.
I would answer that though. So first of all, I'd pick some doors, just like you said, as developers, and you're going to be running on your plugin all the time. And for me, at least when we're at Sonics, it was generally Cubase on Nuendo for anything that was VST related, and then obviously if it was AEX, we're running up Pro Tools. And if it was AU, we're running up Logic. And I think just recognizing, hold on, Steinberger wrote the VST standard. Let's make sure it works in Cubase first. If it doesn't work in Cubase, you've definitely got a problem. And the same for the others.
The one problem I would say with Cubase is I always found that the audio driver would crash if you go into the debugger. So if you hold off on their audio callback, they clearly have something which is checking that. And it would quite often stop my sound card. It may have been fixed in the intervening time since I last built a plugin, but I always had problems with that.
So I had that with a lot of audio interfaces. Use Focusrite.
Yeah. I've got to say, long before I worked at Focusrite, I had a 2i2 on my desk, and it was the sound card that I tested with for years because it didn't matter what we did, it just kept going. It was like a tank.
There's only two we could ever use at Sonic, so we found that crash all the time. Others were Focusrite and RME.
Yeah, RME, but RME was too expensive for us to put on every developer's desk. But other than the hosts, so plugin validators, almost all of the plugin formats now have validators. So there's AUVal, which is specifically for audio units. It ships with macOS. There's also a version bundled in with Logic. They are slightly different. Get to know the nuances because it matters. In certain cases, you want it to pass validation with both. I shipped a plugin that passed validation with AUVal that ships with macOS. Didn't work in Logic purely because of the difference in the implementation. And it can be really aggravating when a user's like, I'm using this specific version of macOS. I've run AUVal and it fails. And you're like, well, I'm on the exact same OS with the same AUVal and it passes. What's going on? And the answer is because when you run it up in the GUI in Logic, it calls its own internal version. And you can directly call that by just passing the path that's inside Logic. It's worth running both of them for sure.
One thing to warn with the AUVal on modern machines is either you're going to need to disable SIP, the security integrity protection, or you can just move AUVal into a different location on your thing. Just literally just take the executable and put it somewhere else, copy it somewhere else, and then you can run it. Otherwise, Xcode won't let you run it.
Yeah, it's a single binary. What I used to do actually was to have a known version of AUVal that I would put in a binary folder and check it into my repo so that I knew CI was running the right version.
If someone hasn't run it, worth remembering, actually AUVal itself is a script that calls AUVal tool. So you can't run AUVal from Xcode, you have to run AUVal tool. All it does, I think, by default, at least it used to, just make sure that it would default run in 64-bit or something like that.
So the next thing, and the one that I would recommend for everybody, Plugin Val by Dave Rowland. There's a link direct to his GitHub page there. It'll test VST 2.3 and AU. Really good tool. Used it a lot. It will catch all kinds of silly problems. I used to use it quite a lot for catching problems with authorization when the plugin is running up. We used to do some really dumb things like starting off asynchronous things, and plugin val will start it up and shut it down almost immediately, and your asynchronous stuff will crash. So definitely worth checking out that. That's open source, totally free. Buy Dave a pint if you see him in the pub. He's always around. Great tool.
I literally was, when he released this, I was actually in the process of writing a plugin validator. I was halfway through, and then he released it. I went, it's fine. It's done. Yeah, so this is great.
Other than that, there's the VST plugin test host. It's only for VST3. It's part of the Steinberg SDK. So it's in the tools folder, or it always used to be. So run that one up. It's only for VST3, and to be honest, I've only ever really run that one up on Windows. I don't remember having ever built VST3 on Mac. I don't know if people do more these days, but I never bothered.
We certainly were building it on Mac when we were at Sonox. I guess we had quite a wide audience, but from what I recall, I remember they did have a command line version, was the VST3 validator. There was also a one, if you got old VST2s and you want to test them, I think it was called VST2 Doctor or something like that, or Doctor VS. Yeah, there was like
so Tony Bear back way when wrote a really good VST2 test host called something like that, like Doctor VST. But to be honest, for anything like that, use plugin val. It's just more modern, does the job really well. There's also, I didn't list it on here, but there's the AAX test host, which is part of the AAX framework. For anybody who's doing AAX plugins, you should probably know about that one. So get to know the validators. They will help you in terms of, is it a valid plugin for a start? Do you have issues with startup, shutdown? They will quite often show up interesting little. Obviously this is all a bit more end-to-end testy, but if you're doing AEX, you have the paste sign-in aspect, and you can use their wrap tool, and you can actually do validation with that as well. So you can actually validate you've probably implemented the license stuff, which is really handy to have that in your test. It definitely caught stuff when we were at Sonox to have that kind of thing. So then just quickly, the other things that I would draw back to is the testing pyramid. So if you start to think about what you want at each level within your plugin and how you can test it, everything we've talked about so far, like we say, is essentially that end-to-end testing. You're testing the whole plugin, but you can break that plugin down. So at the bottom layer, we might have components, presets, DSP, event generators. They can all be tested independently of each other. Next level up, you might have any kind of interaction that most hosts might have, so set parameter, get parameter type interactions, and especially if you can abstract that, it's great. Load and save, serialization, all those kind of routines, they can be tested separately. And then at the very top, that's where we're talking about the validators. They are, that's the icing on the cake. Make sure you do it though. Make sure it's run every time you want to do a release.
I think with plugins it's even more important than it is with a lot of things, because not only have you got the variables of the operating systems, different versions, you've got the variables of all the DAWs. And I know one thing Dave tries to do with the plugin validator is to emulate the different ways that certain DAWs actually try to do things. And this is another one where it's almost like treating your DAW like a QA, in that if a user comes to you and says, when I run it in XYZ DAW and I put the loop markers here and I'm running at this tempo, it doesn't sync, that you need to write a test around. You need to understand how to reproduce that within your test framework, and then you need to fix it once you've got that test, because then you fixed it. And it also means that when you make a change in your sequencer engine in the future, you don't break it again. Because otherwise, how do you know that user's not coming back saying, it was working and now it's not? We're running out of time, but I guess the only other thing I wanted to add there was just if you think it's not testable, like for example, for a long time we were working with the paste stuff and we had Eden integration, and you can mock a lot of those things in order to get some of the testing out, and it's really worth looking into that sort of mocking the stuff. And I think something we didn't get to dive into in as much detail. And taking on the stuff we were showing about how we've managed to get a cache 2 running alongside Juice, stuff like that will help in testing like your components and things like that. So just trying to really spend some time in it. It's easy to dismiss sometimes, and myself included. I think sometimes I'm like, oh no, I don't think we're going to be able to test this. Actually spend some time on it, and you normally find there is a way you can get a pretty good coverage of testing, running pretty fast as well. That gives you a much higher level of confidence.
So we're going to share these slides. So, for example, the mocking and stubbing stuff that we didn't get to sort of slightly dive into today, you can refer back to them afterwards.
We're pretty much out of time. One other thing we wanted to touch on is we are actually hiring at the moment. So if you write good tests, if you like BDD, if stuff we've been talking about sounds exciting and interesting, let us know. All the jobs are up on Workable. We'd love to hear from you.
I'll add to that as well. Actually, there's even a couple of jobs that probably aren't up there yet. I know there's some that we're going to have up there soon. So
yes, keep an eye.
If you've got C++, keep an eye. If you've got C++ experience or even IELTS experience, that kind of thing, you can always send something in to us. And certainly when those roles go up, if you send something in, so there's Rob Steed. If you send something to Rob Steed, he will take that on, and as soon as the role's available, he'll be like, hey, the role's come up, that might be suitable for you. So there's no need to wait until they're there.
Cool. All right. So I guess if there's any other questions, you can let us know on the Discord. I'll try and be around for a bit, for like an hour or so after this, but I'll keep an eye on the Discord and stuff. Just let us know. And thanks everyone for coming.
Thank you.
24 of you. So
held it out for the long haul. Nice one.
Yeah.